Thanks for sticking with us, everybody. Jerry Buxton, Vice President of Engineering for AMSAT.
Close your distance on the mic.
Okay.
QRO.
And I'm going to talk about foxes and more. You know, for probably 6 years now, Tony Montero or myself have come up here and said, let's talk about what's going on with fox. This year is going to be slightly different.
Yeah.
Audio?
Audio.
Al, you want to get plugged in?
I can.
Front corner on the back, which is audio out.
Sorry. That's okay. Okay, start again. If I keep at this, I won't even have to do the whole show.
Five, 4, 3, 2, we got launch planning ignition, and we have liftoff of the United Launch Alliance Atlas V rocket for the NRO L-55 mission to the National Reconnaissance Office. You're hearing the voice of Rob Gannon providing launch vehicle assistance.
Is this slow motion? That's real motion.
It's really slow.
Wow.
It's a little over 1G. It's very slow. It's amazing.
Yeah, that's the real wrong.
See it.
How many miles
We're
away?
probably 5.5 miles away, 5 to 6. That was the view from the ULA hangar at Vandenberg Air Force Base that those of us who got to attend the launch, absolutely flawless, which, as one of the NRO gentlemen we worked with commented, it's kind of spooky. The 4-minute countdown that we tuned in out as we were standing outside there was the fastest 4 minutes I've ever experienced. The 4 minutes after, before it disappeared from sight, was the longest 4 minutes, so it was pretty cool. We had the good fortune of being able to invite a lot of Tony Montero's family to go to the launch. And we had his wife, Mary Lou Montero, his daughter, Veronica, who is, if you don't know, is the voice of all of the Fox 1 satellites in the ID. Lisa Montero was there, Michael Montero, and some of their family. And now AMSAT Fox 1A is AO85. So this year's a little bit different. Thank you. Some early observations. As you know, we turned on the transponder very early. There were a couple of reasons for doing that. One of the biggest benefits is that it gets us a lot more telemetry than when it's floating around in safe mode and we get a beacon every 2 minutes. It gives us an opportunity to see telemetry not only for the satellite, but as well for the experiments, the Vanderbilt experiment specifically. It looks like we've got a good battery. There was concern that sitting for 6 months with no charge was going to start with a very low battery, and that we might have a problem with that. But it charged up very quickly during the approximately 50 minutes that it had after deployment, before the antennas were deployed and the transmitter turned on. It looks like we're getting very good power from the solar panels. The temperatures are warmer than what we had predicted. Everything was basically built for 0C. And we have heaters on the batteries, which we won't need, which is good. The temperatures being warmer, there was a little bit of concern initially. We saw them go up quite a bit toward the beginning. They're working their way back down now as it tries to reach some equilibrium. The good news is it's not anything bad, and in fact is very close to the temperatures that a lot of the testing was done in the Fox labs at room temperature. The Vanderbilt radiation experiment is working very well, and they're elated with the science that they're getting from it. We were able to provide them, through you, everybody who's copying telemetry, with some data within a few days, and they are very, very happy with what they're seeing. The MEMS gyro experiment provided by Penn State Erie is, if you are running FoxTelem, you'll notice that the numbers, and if you were trying to watch it to see what the spin rate is, you'll see that they're very wild, but that was to be expected because they do a warm helium purge before the launch, and we knew that that would affect the MEMS gyros. The question becomes, how long will they stay affected? Tony had apparently done some testing early on that indicated that perhaps within a month they might stabilize. We'll wait to see about that. We'll have to see how that plays out. The downlink signal is very strong. There were quite a bit of fading initially. That seems to be slowing down as it stabilizes. It may take a while longer before it gets into its magnetically stabilized pointing plus Z toward the north magnetic pole type of configuration. We expect a spin rate. We expected 1 to 4 RPM. The CEPs are found to be consistent with Object 90747. I was talking to some of our guys yesterday and they said it seems to be spot on. And as I mentioned, the amount of telemetry that we're getting from everybody who's copying this is just unbelievable. It's very, very helpful. And we're able to, while we don't have the presentation yet for everyone to go in and see the telemetry through the web, we can take it out, put it in FoxTelem, and look back to time 0 and see everything that's going on. It helps tremendously with everything that we're trying to do to analyze and figure out what's going on with the satellite. Not only that, but your observations. Everybody has been very helpful in sending screen captures or other data and observations about what they see working and listening to the satellite. We seem to indicate that the receive frequency may be 7 to 10 kilohertz low. That is possibly an effect of the temperatures. The transmitter, I know for a fact, was always about 1.7 kilohertz low in Fox Labs at 23, 25C. So what we're seeing on the transmitter is also to be about that difference, which fits in with the temperatures that it's in. So we need to characterize what the receiver is like in regard to that. So we have not done calibrated testing yet. Like I said, we turned it on very shortly after it was deployed because of the desire to gather that telemetry and also the preparation and everything we had to do to get to Symposium. We decided we'd just leave it running until after Symposium so that everybody could play, and then that would give us a chance to get back home and look at it. There's, in regarding the receiver, there's a lot of speculation. We're trying to figure out, we don't have a feel for it yet or an understanding about what might cause the perceived loss of sensitivity of the receiver. So we're working hard on that, as well as what we learned taking that and applying it to Cliff and D. So what we plan to do, after we have all this fun here this weekend, is Sunday night we want to command it back into safe mode. And safe mode, of course, shuts off the transponder. We just get the beacon every 2 minutes. And then we're going to ask everybody, and I ask you to spread the word, to stay off the transponder and let us play with it then for a week. We need to do a lot of calibrated testing. We need to be able to get in the signals dependably. We need to be able to control what goes in and what comes out. We'll be putting it in data mode probably. We will probably also be using it in transponder mode so that we can test it ourselves and look at what we have. I ask that if you hear it, you stay off it, and hopefully within that week, Monday through Friday, we would be able to complete our testing and we can put out an ANS the following Saturday that the thing's back on the air. Your cooperation is very important. True?
As well as ANS and AMSAT-BB, keep an eye on the AMSAT Twitter feed and the AMSAT North America Facebook group. Both of those are near instantaneous, and that's generally the first place I post when we do mode changes.
Thank you.
Could you just please also clarify what is safe mode?
Safe mode is a mode that we have that shuts off the transponder in the experiments. It is intended to be used if the battery gets too low. It will automatically shift into safe mode. If we find that there's an anomaly that we want to have a look at and take some time to look at the telemetry, we don't run anything running while we're looking at it. It will do that. Safe mode will beacon every 2 minutes, and it sends a real-time and then alternating every other beacon, either a high or a low telemetry frame. Transponder mode, because as long as I'm explaining it, is the active get on the air and talk mode, it contains that DUV data, which is the same as what you hear with the beacons. And if nobody's using it, every 2 minutes it will also do a voice ID. You can tell the difference between the two because the safe mode ID says Fox 1 safe mode. The transponder mode ID says, hi, this is amateur radio satellite Fox 1. So that's one clue if you hear it going by and nobody's on it to know what mode it's in. Data mode is our high-speed experimental data mode, 9,600 bits per second. We will be using that a little bit because we can get data much faster. You're getting a frame every 5 seconds. So in some of the testing we're going to do, we will use that. It is not necessary for Fox 1. It was designed to be there simply as a proof of concept. As everything developed, it looked like it could be used for the Virginia Tech camera, so we had planned on using that. However, with Fox 1A without the camera, we don't really have a need for it, so it will only be used for testing. Fox 1 Cliff and Delta, they will have the camera and the Herky experiment, which require the high speed. So yeah, your cooperation with getting this tested and staying off the air and helping your friends understand that is greatly appreciated, because the faster we can get to it and the more time we got with it, then the faster you can have it back. Thank you for your support. Now we can talk about what we're doing with Fox.
Let me say something, Jerry, first before you go on. It was a pleasure to be able to issue AO45 to this satellite and to commend you and to commend Tony on their fine work.
And that was a wonderful commendation, and thank you, Bill. Fox 1 Cliff, Fox 1C, recently renamed to Cliff in honor of Cliff Buttschardt, K7RR. Fox 1C is going to be a little bit different as we've had more time to develop it, obviously. Fox 1A was intended to have a maximum power point tracker power supply. We did not get one developed in time to be able to fly it. It was quite a chore to come up with something that would work that small and on the voltages that we're using. The Salmi brothers, Bryce and Brent, who you may be familiar with, they actually, as their senior project, worked on a maximum power point tracker that Tony had asked them to look for to use on a Fox 2 series satellite. They were able to take that design and use it as a basis to engineer the MPPT for Fox 1's CD and B coming up. And so we will be flying that for the first time on these two, but we do expect it will deliver a lot more power. The initial concern was with the simple voltage regulator power supply that's on 1A. If we were running cold like we expected, a lot of power is used in the battery heaters to keep warm just so you can charge them. You need to keep the NICADs above 0C. Fortunately, we're not seeing that, which is great. We don't need to worry about that, at least at this point, as far as the power budget. And the MPPT ought to be able to provide wonderful power for the more high-speed data that we're going to be using with C&D. It'll also carry the Penn State Area Gyro experiment. That's built into the IHU. When they originally made the design, they did not finish a flight unit before they graduated. Rather than take up one of the experiment slots by building a flight unit ourselves, we decided to incorporate it on the IHU because it had a lot of extra real estate. The Vanderbilt ISD radiation experiment, which was the spare for Fox 1A, will be flying on Fox 1 Cliff. So it's a duplicate of the one that's up there now. The Virginia Tech camera will be flying on Fox 1 Cliff. There are two versions of that as it developed. And you heard Seth talk about it earlier. As recently as 9 o'clock last night or so, we had decided what we were going to do with that, and he incorporated the changes. So Fox 1 Cliff will have a camera that's identical to Fox 1D, with the exception of some of the firmware. We're only going to take the 640 by 480 pictures with Cliff. And you'll be able to receive those with the Fox Telem program. It does a wonderful job of capturing those. And then we have the L-band uplink. It's called Downshifter. That's the name that John Klingelhafer came up with it. And it's going to use, I forgot exactly what the frequencies are, but they're 1268 point something. And convert it down to 435 point something, which is the same UHF uplink that we would use in the UV mode to provide opportunity for an LV mode. It's simply rising the experiment 4 slot, the top slot of the stack, and is switched in and out of the antenna line to down convert or bypass that to the receiver. Fox 1D, pretty much a copy of C. It's got the MPPT, the MEMS gyro experiment, but here we hooked up with the University of Iowa a little over a year ago, and their students built what's called the Herky experiment. Herky is their mascot, a hawk, H-E-R-K-Y. They call their experiment Herky for high energy radiation CubeSat instrument. It is a updated version of one of the experiments that Dr. Van Allen flew back in the 50s. So the students have had an opportunity to use newer technology, and they're going to map radiation. They will have a bunch of data gathered all around the clock. Once every couple days, when it goes over to the University of Iowa, they'll kick it into the Herky mode, high speed, download that data. Of course, you can copy it, everybody can copy it. They have a little bit of data that's available in the slow speed. As you know, and I'll reiterate, everything that we do with these experiments, the camera, everything on amateur radio has to be open. So anybody can receive it, anybody can use the science, and you can also get into the server where we put all of that and access it for use as well. Virginia Tech camera flies on D. This version of it, if you will, again, it's identical to C, but as Seth explained, they found a reason to want to take a picture in the 320 resolution, so that will be set for 320. We can command it to the 640 if we want to. We're planning on running basically two different ones since they're launching together to be able to see what the differences are. We have the L-band uplink as well on D, so we'll have two new L-band satellites up there. The flight units are being built as we speak. I did put a little bit of a hold on transmitter receiver to see before we coat them, basically, to see if there's anything that we might discover from 1A that we could apply to that. These are just some pictures I threw in for eye candy of the Fox Labs with the various things laid out. You have upper left is the camera being tested, where I took a picture of Earth, I would put it against a black background, set the camera to zoom in on, use varying light levels, because as Seth mentioned, we cannot take pictures of anything but Earth. If we take pictures of space, all the three-letter agencies will be upset, so I was testing it to the best of the ability with the lighting in the room to determine what we could do. That's also how we came up with that variable sensitivity to light. That's what led us to do that, because it was taking pictures of naughty bits. Lower left picture was some of the first testing of the MPPT in the stack. The center picture is a couple of the flight IHUs when they came in. Upper right is just a general look at with the camera pointing off toward the picture there. Below that, stack sitting on the desk with HD SDR and my FunCube dongle running in the background to listen to it. And the lower right is the Fox Mobile. Anybody whose wife is a teacher of pre-K, you get free stuff like this. So it's really great for taking it out and testing it in the sun. I can put it in there, cushioned ride, and reposition that little puppy so that I can, point different panels toward the sun and stuff. We do things on the cheap, right? So work with what you got. RadFxSat is our fourth Fox project. RadFxSat was a CSLI submitted by Vanderbilt University, I believe in 2012, so just a year after the Fox 1A. And they are the primary on it, but it is a copy of a Fox 1 satellite that we participated in them with. It was recently selected for the Alana 14 program, and will launch. They've sticking to November 15th, 2016. It'll be a sun-synchronous orbit on a Delta II from Vandenberg Air Force Base. Fox 1B will be a Fox 1A type configuration, with the FM repeater, the MEMS gyro experiment, and it will be all Vanderbilt experiments on the top part. And we're not out of Foxes yet. John Klingelhofer, working a little overtime, came up with the idea of flying a linear transponder. Do that again, please.
So you're fine on time.
Oh, okay. So he put the idea, he said, what do you think about flying a linear transponder? We were thinking about, at that time, that it looked like there might be an opportunity to launch a Fox 1E this year. So we said, okay, let's look at that. Turned out that launch didn't come through, but we will have leftover Fox parts. When you build something like this, and you go to advanced circuits, which is where we go, and you want 4 circuit boards, it's $1,000, or you can get 8 for $1,100, right? So we buy more. So we have bits left over. We will fly, the plan is to fly a Fox that has about a 30 kilohertz, not about, it should be, 30 kilohertz linear transponder. This one will be a VU, VHF uplink, UHF downlink, on what we would call Fox 1E. Fox 1E then, it turns out Vanderbilt contacted me a couple months ago and said, we want to do this again. We want to submit another CSLI. Will you ride along, or will you give us the ride, basically? So we agreed that they were happy with the linear transponder, the 1200 bit per second BPSK downlink for telemetry. Their telemetry is fine and slow speed. They don't need the high speed. So they're really cool with riding along and getting and using our Fox 1E transponder for their telemetry. So it will be another one with the, I guess I mentioned it, the MEMS gyros. They're going to test something new in this one called these FinFET devices. And what they had tested before, it's basically SRAM. And they're looking for upsets that are caused by various radiation. And so they're going to try some of the new FinFET, which are supposed to be much more tolerant of the radiation, make measurements of that. We also have, and Luigi spoke well of this earlier with a couple others, the CubeQuest Challenge Ragnarok Industries project. This is something that came about over a little time, as he mentioned. It was about a year's worth. It coupled in very well with our start of the ASCENT program, which I mentioned back at the Dayton Hamvention. And so we set to work on building a radio that would not only serve for them to be able to run and control the satellite, but will offer us an amateur radio transponder. In the initial work with that, as things were decided, the 5 and the 10 gigahertz was settled upon, and that is what became the basis for all this other 5 and 10 gigahertz stuff that we're trying to work with. Once they're done with the CubeQuest, and as you mentioned, they'll turn it over to us as an amateur radio transponder. Any work that we do on it is something that I'm going to expect to be able to take away for our own 6U satellite as well. So we benefit not just in assisting them to get one on the moon, but in something that we can also use in an HEO around Earth. So the 5 and 10 gigahertz I mentioned goes along with the ground terminal that you've heard a lot of discussion about. This is something that AMSAT wants to build to be easily available, $500, $1,000 if you buy it from us, or whoever markets it. The idea is to keep it reasonably low cost, but in the initial discussions about that, it became clear that I'm not going to go out and pay $500 for a ground station for CQC, for example, and then a different ground station for the P4B and a different one for P3A. So I came up with the idea, let's make everything 5 and 10 gigahertz. We develop all this. It's especially great for the CubeSats because VHF and UHF gain antennas, on a shoebox get to be pretty tough. So by moving up to the microwaves, as we are also losing many bands, as you may be aware, we have got to start using them. Use them or lose them, right? So the 5 and 10 becomes something that is not populated right now. A lot of reasonably priced stuff is available to work with that. It fits into the footprint we're talking about. It also works with Phase 4A, which is the SHALE-2 that is being launched that the European transponder is going to be on with a 10 gigahertz downlink. So by doing this, the idea is that if you invest in this new ground station, it's good for the new generation of satellites. Kind of like VHF and UHF was the staple for many years. I've got, big Oscar, huge antennas up in my attic, and they've been good for a number of years. But you got to move on with the technology, right? I won't cry when I take them down, but this way, I see it as that everybody can be comfortable in saying, yeah, I can spend that money, and it's going to last a while. It's not going to be a one-shot deal. So it'll be an open design with an SDR. A lot of this was discussed. Useful on all these satellites. Targeted at retail $1,000 or less. There is some software development going on in Southern California. Tom gave an excellent talk this morning about some of the hardware development that's going on with it. All of this couples together with all of these projects that are going on. So regardless, P4B, for example, doesn't get accepted or doesn't fly, we still can use the ground station for the other projects. P4B and Phase 3E has been talked about a lot too, of course. Virginia Tech's the lead on that. Bob brought these to us and said, here, you don't look like you're doing anything. You want to help us with this stuff? So, we're hams and we love satellites. It's hard to say no, right? So, we're going to collaborate with them on providing essentially volunteer labor, a portion of what goes on with that. The ground station, of course, is a major portion of it. The RF portion on the satellites will be undertaken. We're going to have a meeting tomorrow to discuss what we can do and how we can do it to best work together with them to achieve this. We want to be involved in it, but we also don't want to overcommit. We are fortunate right now to have all of this stuff go on. It was for years, like I said, 6 years, well, Fox 1, we're going to do this. Fox 1, we're going to do that. Well, now we're doing all that. We've got these things coming along. We've got the QQuest challenge coming along. And we don't want to overcommit that with an all-volunteer workforce. So those are still, the development of those are still in progress. They're not promised yet. And we have to wait and see what the outcome of that is. I just wanted to mention something I just thought of. The development, the work on Fox 1A was tens of thousands of hours by at least 100 volunteers. There's a lot of stuff that goes on into these. Volunteer hours get to be very long, and it's difficult because we all have a wonderful life, right? So it's hard with volunteers to make a commitment to a specific deadline. No matter when the launch is, I'm learning that we're going to finish about a month before that. So, it can slide out there 2 years and we'll finish in 1 year and 11 months. So that's what I want to make sure we don't overcommit on. I don't want to say we're going to do something, we don't get it done. It's better to pay to make sure that we get there if we have to, but we sure as hell want to give it our best effort to get there. Some other things that are on the horizon in the crystal ball. We talked with the University of Washington last year and then recently again a month or two ago. They're going to submit a CSLI. They were looking to us for a payload, and we agreed that we would provide them with a Fox 1E type transponder. So we have another opportunity here for a linear transponder to fly on a 3-unit LEO. The HEO has been talked about a lot. The plan is, as I said, with the development that's going on, especially for CQC, but as well for P4B, with the 5 and 10 gigahertz, that's something that we can take and stick on our own 6-unit satellite. We also have to learn if we're going to do that and send it up there to do attitude control. So there's a little bit of work to be done on that, but this development just fits right in with that. Anything that we do, we can take away with us and use on our own. We would not, there was talk about submitting a CSLI for a GTO. I would not do that this year. What we need to take a look at are 3 things. One, the most important are, does P4B and P3A come off? Because if they do, we're not going to have time to work on a HEO as well. We don't have enough people. If they don't, then we're able to go to work. So next year we could submit a proposal. We could have it tight. We're getting a lot of interest and interaction with universities and people that are interested in flying experiments, which is what gets you those free launches. So we'll work on that for 2016. I'm going to try to speed it up a little bit here. The idea last year with the design of the next AMSAT satellite was to look for ideas, as at that time we thought our next step was going to be like a 3U, Fox 2 type of thing. And that was great then, but it wasn't very shortly thereafter that Bob came to us with the other projects. So we still look for that. I expect that we want to stay in low Earth orbit. We can get cheap launches, we can get free launches, we can have a transponder, used or not, and lots of satellites. We can provide universities with radios to fly, like University of Washington. We don't have to build all of these. But the experiments, the STEM, especially in that bit I did with NASA last week, it became very clear how important what we're doing by flying these experiments, by making this all available to anybody with a radio and a little arrow antenna, essentially, how important that becomes. These are the people that need to replace us. There's some young people out there, there's a lot of old farts out here. And we need to be able to have people that are interested in this and want to keep going. And finally, a request regarding that. Over the years, AMSAT has had relationships, a lot of times inside NASA and other organizations, because many of our members worked for them. The landscape's changing as the generation does, to now it's more of an external relationship with those entities, but it is something that has been cultured over time. The relationship with NASA, the relationship with NRO, the relationship with these universities is priceless. and it is very, very important in where we go. Along with that, it's very important that we appear the professionals that we are. And I would like to ask for your cooperation in discussing, in representing AMSAT as members, that we be careful about how we present ourselves with these organizations. We expect that, for example, Fox One, you guys got a lot of, I can't tell you, from me. NRO either didn't tell me or told me and I couldn't tell you. The same thing happens with C&D, Cliff and D. We have I know everything about those, but we have a non-disclosure agreement, and I can't tell you what I know. I can tell you certain things, and I have to wait for them to tell me that I can tell you certain things. So we don't want to spoil that. We want to honor that. We want to work with them and let them invite us back to fly again. So please try to keep it easy. You know, don't be, everybody wants to know when a launch is, for example. But don't be jumping up and down calling everybody. When are you going to launch? When are you going to launch? Yeah, you might find out on the internet before we can tell you, but we will tell you as soon as we can. And that is all I have for this presentation. I would like to...
Oh, yeah. Okay. Okay, go ahead.
I'd like to ask, there's some members of the Fox team here. I wanted to ask them to come up front so that we can take some questions and we can be represented in the hardware, software, ground terminal, and all that kind of stuff. So if you give it just a minute, we'll assemble. And give them a hand. These guys all work very, very hard. Go ahead. Come on, Jerry. Introduce yourself.
Okay,
Ready?
well, we're going to get something I have.
Okay, I'll ask
I
the
guess let's
questions.
check.
Does anybody have any questions?
Get closer together, that's the first thing.
Okay, photo.
Which way?
This is...
Group photo.
Sing by Oscar. Thank you. I'm going to let everybody introduce themselves first. Tell you what they do, what they did for Fox real quick, and then we'll take some questions.
Yes, why don't you go ahead and
I'm Brian McCarthy. I did some work on spin rate calculations from solar cells.
speak up.
Well, just hear the thing. Right.
You want to say it again?
Brian McCarthy, I did some work on the spin rate calculation from solar cell data.
There you go.
I'm Chris Thompson, AC2CZ, and I wrote the Fox-to-Land ground station software.
Jonathan Brandenburg, KF5IDY, IAG software primarily around the experiment and the downlink.
All that telemetry.
Burns Fisher, I worked on the Fox Flint software.
Taylor Klotz, K4OTZ, worked on the RF, played with John, and the command transmit uplink.
I'm Bill Reed, NX5R, and I worked on the IHU flight software. Questions?
I got Drew last week too.
They all know who I am.
And if you got any questions about the operation of it, because he will be taking it over here very shortly. Actually, he's been trying to for years.
You said it has a bar magnet that'll follow the magnetic field. You've got a spin. Do you have torque coils? How are you doing it?
The bar magnet's mounted on the, I can't remember what face, but it's off to the side. If you've ever seen some pictures of our stack, you can see it in the stack that I have sitting back there. So there are hysteresis rods under the battery board. The spin is imparted simply by the offset of the solar panels, dark versus light.
Jerry, do you want to make any comments about project management and the lessons learned in doing the Fox program? You want to make any comments on project management and the lessons learned in doing the Fox program?
Yeah, don't put people on the spot. Really, honestly, the lessons learned of the project, we're a week into orbit. We are still looking at what it's doing on orbit. So I don't think we've actually come to a point where you can sit down and look at that. We have looked at lessons learned after we delivered Fox 1. And we did the various groups did a lessons learned about what they had so that we can look, as we went into Fox 1, Cliff, and Delta, the development of those, that we don't repeat some of the mistakes we did. There's a lot to do with it. I've told the board, mostly about the biggest lesson that is really obvious is doing this with all volunteers. It ain't easy. And especially with the distributed engineering model. When we're all over the U.S. and we're talking by email, we're talking by phone, it's not nearly the same thing as being in the same room. Things just go slower. For shipping parts back and forth, the CubeSat's great for that. You can send stuff in a little priority mailbox for $5 and it'll be there in 2 days and somebody can do something with it. But with that coupled with your real life and such like that, it's if you're in the same room, you're committed to doing something because you flew there and you're going to spend 2 days there and you're going to get it done, right? At home, you get a box, you go, I'm supposed to do this, but that's no dinner, so I'll do that after, right? It's just a little slower, and that's the main lesson to learn, is that the time is something that you have to take very much into account, which is, all, like I said, why I don't want to overcommit on any of these future projects.
Thank you.
Anybody else?
Anything?
Anything at all?
Let me say something about lessons learned. One of the lessons we learned in Phase 3D is never build another one as big as that. we had to ship it to Maryland twice for environmental testing, once for thermal vac and once for shake and shock and so forth. It would not, the box, the carrying case would not fit in a Ryder truck. We had to put the satellite, just wrap it up and stick it in the truck, and we had to rent Ryder trucks to transport it. I'd say the Fox satellites are certainly a lot easier to ship than that.
Yeah, if you take a look at the little Pelican case in the back, that's how I delivered Fox 1A. That's how I got that stack here, and I just walked right through airport security, put it on the belt. They look at it in the X-ray and say, "Happy trails." So nothing to it. Thank you very much. Thank you guys.
One more question, real quick. I know you said that there's a lot that either you haven't been told or so on and so on about Fox 1C and 1D. Is there anything you can tell us about how the launch will take place in terms of publicizing it? Because there was a lot of excitement when you could watch the rocket launch and all that. I know this method won't be quite the same. Is there anything you can tell us about sort of how it'll be publicized, when we'll know? Is there anything we can watch to kind of just get the excitement going?
Yeah, I expect with Cliff and Dee that it's going to be a lot more open and a lot more advanced. Some of the things I'm kind of hinting at are, for example, I'm saying first quarter 2016. I know a date, but I can't tell you the date. So it's that type of stuff. The orbit, we're not specifically allowed to say what that will be yet. I'm not quite sure how that all fits in. I'm sure it has to do with making money and proprietary stuff. But I don't see any reason that one won't be well known ahead of time. At least, especially, like I said, through the internet or something else that SpaceX or Spaceflight or somebody's publishing it. Often they forget to tell us it's okay as well. We did that with the NRO on the last one. Everybody knew about it. And I'm calling them up, can we say it now? Can we tell them now? Okay, I'll send the email even though it's going to look stupid, but okay, yeah, here we go.
Well, I'm just trying to plan for getting student excitement up.
Yeah.
It was, I kind of found out last minute. Now I'm glued to the Twitter feed. And that's a really quick way to tell lots of students something really awesome is about to happen. Come out to the tracking station. Let's try to.
And he'll do that. We every time we find out something, we're tweeting in Facebook and in ANS and everything we can do. The nice thing about this launch is that if it slips, or as it slips, because it already has, we go with it. We're not delivering it in March, and they're going to launch it in, maybe August, maybe September, October. So I'm sure that we'll have much more up-to-date info.
If you've noticed, we only recently have said that it's actually on a SpaceX launch because we weren't allowed to before that. At some point, we'll be able to say what SpaceX launch it's on, what primary. Okay. So when that happens, then we won't be sole source for the information as to when that launch happens. So you'll be able to look up when the primary goes in and
And I expect that with RadFxSat too, which you're not as interested in, but that one's launching on Delta II. I forgot what the primary is, but they're much more open with that one. We don't have to deliver that one until 45 days before launch as well, so I'm sure that it will be more visible.
We're going to try to get the president of the university and senator this and that and the other to come watch with us. You get the idea.
Okay, cool. We'll have plenty of time on this one. This is a commercial launch.
I got it.
Start
As
getting
long as
on
we have
space flight now to make sure they have a friends and family like ULA did.
Yes.
Thank you.
Okay, Jerry, very good. I wish you were staying with us. Jerry's next topic is Fox 1, Cliff and Delta, environmental testing.
1524.
Yeah, about 10 or 15 minutes.
Okay. I'm presenting this on behalf of Bob Davis, our mechanical engineer. I honestly received it last night, so it may not be nearly as smooth as my last one, which started out really well, as you noticed. What Bob wanted to discuss was the environmental testing that we did with Fox 1A, which we did at Qual Test in Florida, versus what we're going to have to do with Fox 1 Cliff and Fox 1D. So there's a difference between them in that we have more experiments in Fox 1 Cliff, Fox 1D. We've got the MPPT flying versus the PSU. There are differences because of that in weight. Weight is the primary difference. We want to ballast them all up to be as close to 1.33 kilograms as we can, because the heavier they are, the longer they stay in orbit. You see that the differences between the two, estimated as they're assembled, are going to require different amounts of ballast. The testing is also different. Fox 1A had to go through some severe vibration testing because we were riding right next to the bell, basically, of the Centaur rocket. Some of the testing was up to 22 G in one axis there, so it shook the heck out of it. If you ever saw a little picture of us celebrating after the environmental testing, that was really during the environmental testing, right after the vibe test. Not even after the whole thing was done, it was like, eh. But right after the vibe test where we shook the heck out of it, that was an amazing point in time. So you see that we have 2 times up to 20 G. We only have to go up to 15 G for Cliff and Delta. Cliff and Delta also have to go through a centrifuge test, which is something that we didn't have to do with Fox 1A, and they will have to have a shock test. The shock test is going to be offered by Tyvek out in California to try to get everybody together that's going to be in the same cube. Here's some photos from the vibe testing we did with 1A. We met in the hotel room early in the morning and did some pre-measuring of it, put it in the test P-pod, took it over to Qual Test. The exciter there, we had to have a special plate drilled to hold the CubeSat because they've never done anything so tiny. As a matter of fact, Bob spent a lot of time working with them on how to accommodate and work with something as small as a 1U CubeSat. If you've never seen a vibe machine, it's like really kind of like a giant woofer, and they feed it with acoustic energy. It's a giant speaker with a plate on it. So that big blue thing on the right is what that is, and it vibrates that plate in and out at various frequencies and amplitudes based on what they feed into it. When they did the third axis, because we don't want to take it out of the box and rotate it and put it back in the box, they simply rotate that drum up and bounce it up and down in that third axis. Yeah. This is the receive antenna on Fox 1A, AO85. When we got all done with everything, and we took our final look at it, we exceeded the, I believe, 6.5 millimeter envelope on the -Z by 0.7 millimeters, because the receive antenna, apparently, you see it's tied by the fishing wire. Oh, that post up there is what tells us if it's deployed or not. It's conducting. So the fishing wire then goes down around a standoff on the side, wraps around the burn resistor at the bottom, and then is tied in a knot. When we think that what happened in order for that to protrude is that when Bob tied the knot, he tied it kind of on the side of the post. And as it vibrated, that knot tie point moved around the post, put a little slack into the whole setup there, so the tip of it got 0.7 millimeter more of string, if you will, in order to hang up in the air. That was one of those gee whiz moments. And at that point in time, we quickly got a hold of Cal Poly and said, you know, we got a problem here. He said, we'll talk about it. It turns out in the accommodation that we were, because we were the heaviest, at the bottom of the peapod, if you will, that the antenna protrusion was touching against the pusher plate, so everybody from the launch services was very happy that it wasn't going to cause a problem. It did not touch the side of the peapod, and resting against the dispenser, if you will, didn't pose a problem. For the bake-out, there's a giant bell jar. They have heaters, which actually we're probably going to use the same setup for C&D and try to do C&D both in the same. We take the test peapod, no, we took the CubeSat. You apply a couple of, I forgot what the word is, anyway, temperature reading things. Thank you. And you put it in the bell jar. We lowered the vacuum slowly, heating it up to about 60 degrees C for about 12 hours at 1.5 times 10 to the minus 6 torr. It was really clean for a satellite that was built at home, essentially. Everybody was very impressed with the fact that because if it's dirty, you get a bunch of particles in there that bake off. That's what this is all about, baking off all your fingerprints and your cat hairs, and they weren't mine. And all that good stuff that gets in there. So to see the vacuum go so very low was a good indicator that we did take very good care of it. We had to hold that temperature for 12 hours, and he might mention some more about that in the next slide. But when we do Fox Cliff and Fox D, because they each may have to go separately, if we can put them together, that'll be great, but probably going to wind up with them separately. You cannot take your eyes off it. We have to bake it for 6 hours at 50 C, then come back and do the 6 hours at 60 C. So it takes a lot of time from the technician as well as the Fox team to be around and monitor that, because if the temperature goes below 60 or the vacuum goes above the test limit, you got to start all over. The lessons learned and results from this, all the Fox 1A tests passed with the exception of that protrusion, but the environmental tests were very good. Mission readiness review was confirmed and launched. The suspect antenna loop that moved, we got a little waiver for that. Future Foxes, lesson learned, tie that knot more consistently. The bell jar box was heated but not cooled, so it took us a long time. Part of the 6 hours at 60 C really isn't that long, but by the time it cools down after 60 C, so that you can pick it up and go do anything with it, took a long time. That adds a lot to the bake-out testing. So we're looking that they're going to be able to supply us a base with active cooling for this next round. The Fox 1 bell jar was vented with oily shop air. Just when it was the cleanest, future Foxes will be vented with nitrogen. A lesson learned for qual test in that case. Fox 1A, one of the two thermocouples may have shipped under the tape. They put it in a metal box after they put it on the platform for the bell jar. The metal box was basically a little hat to help keep the temperature consistent with the inside of it. And we're thinking that somebody might have, putting that box together, bumped a wire and moved one of the thermocouples a bit. We still got good readings, but it wasn't on there tight like we would have liked to see when we were done. I can answer questions about it better than I read that because I didn't quite know what he was going to present, if you will. So, are there any questions? We will go back to qual test to repeat the same thing this year. They did a very good job for us. The fact that they have that plate on hand helps a lot, and that cuts the cost for us this year. Chris?
Is it very costly, Jerry, testing?
I'm thinking that it cost, and this is a pull out of my hair, I don't know if Keith's here, but I think it was about $11,000. The date of next test. I will discuss that with you in private. We're looking at December. I just don't. I don't know. Yeah, and I already. invited some people, so if you're not listening. We'll do that. We'll meet out there. It'll probably be about a week and a half deal to do that one.
We got an estimate from Goddard for just that bake out for our little CubeSat, and it was $20,000.
Really?
So we just did it in our chamber that night.
I think that one thing that we did find with Qualtis is, like I said, it was their first CubeSat. We also donated to them, if you will, the block that they had to drill in order to hold it, so that they could use that to attract other business. And I think that had to do with a little bit about us bartering there to get that done. All right, thank you.